Hi, I'm Peter, and I'm going to show you how to make your very own hockey scoreboard. You might be wondering why one would need their very own hockey scoreboard. Well, I have an 8-year-old son that plays hockey, and not only does he like ice hockey, he likes to play something called mini stick hockey. These are mini sticks. I play with them all the time, and we set up a couple cardboard boxes and we play hockey on the floor in a room in our house with this little foam ball, because sometimes you get hit with it. Games get pretty intense because we're both very competitive, and we need some way to keep track of the score, the time of each period and the periods, and also we need to know when to do our sellies. So I went to work on this hockey scoreboard for him, and I'm going to show you how I made it. We live in Maine, so obviously we are Bruins fans, so this is themed around Bruins. Go Bees! And we've got yellow buttons, we've got the Bruin bee, a clock that counts down. We have buttons on the back here that you can select the period. So if you want to do a 12-minute period, 15, 20, 5, you can select the period number. There is the period time, and there is a play pause button. So when you press this button here, the clock will start running and it'll count down to 0. When it hits 0, you'll hear a end of period buzzer. When the period changes, there is a period button. You can change the value of the period display there. There are only 3 periods in hockey for those who are not initiated. And we have a score reset button. If you're not familiar with hockey, there's something called the lamp. And every time you score, the lamp lights up. So when you score, it's called lighting the lamp. And if you press one of these score buttons to tally a score for the guest team, it lights up. And it also creates that horn sound. Now, after that sound, a song plays, which I don't have the copyrights for, so I'm not going to continue to play it here, but it's a song that plays whenever the Bruins score at their home ice in Boston. Before you start the time, these buttons are not score buttons, they are volume buttons, so you can actually increase or decrease the volume. Once you start the time, they turn into score buttons. And you can stop it short by pressing the play pause button if you don't want to go through the whole rigmarole of the lamp and song. This is all 3D printed. It's made with an Arduino Nano, a mini DF player, and I'm going to show you exactly how I made it. All the files I used to make this are going to be linked below in the show notes. If you have any questions, leave them in the comments, and here we go. The hockey scoreboard project started out as a drawing. I like to draw everything out before I start to have a clear idea of what I'm going after. And so this is the very first drawing I made of the hockey scoreboard before I started building or buying parts. It also gave me an idea of the dimensions, if it would fit on my build plate for my 3D printer, and gave me something to work towards. For the clock, I chose to use Adafruit's 1.2-inch 4-digit 7-segment display with I2C backpack in red. Using this part really simplified the clock for me. So the first step is to solder on the backpack. And guess what? I messed up. I soldered it on backwards. So I bought this $40 desoldering iron off of Amazon. Make sure there's plenty of solder on the pads before you try to desolder. Then you heat up your iron, you stick it over the pad and suck the solder away, and it worked. I was very excited how easy it was to desolder those pins. So make sure it's lined up with the silk screened image. Before you solder, line it up properly and then solder it on. Then solder on your wires. I made them extra long because I didn't know how long I needed them yet, and I can always cut them down. So this is a shift register. What is a shift register? It allows you to control up to 8 outputs off of 3 pins on your Arduino. Each segment on the display has an LED, and it needs 1 pin from your Arduino to control that LED on and off. I'm using common cathode displays, so the middle pin on the top and bottom of each display is is a common cathode. That means they all have common grounds. Let's go through the pinouts of this 16-pin shift register. Pins 1, 2, 3, 4, 5, 6, 7, and 15 are the outputs. So you can make these pins go high or low. Pin 8 goes to ground. Pin 9 is the serial, the data output. So if you're daisy chaining these together, you're going to send this pin to the serial data input on the next shift register, which is pin 14. You want to bring pin 10 to high, so that goes to 5 volts. Pin 11 is the clock pin. Pin 12 is the latch pin. Pin number 13 goes to ground. Pin number 14 is the serial data input, like we mentioned. Pin 15 is again an output. And pin 16 is your voltage input, your VCC. We have our two 7-segment displays that we're going to connect. We put a 220 ohm resistor on the common cathode, which is ground, and send those to the ground rail on the breadboard. The top left pin goes to pin number 1 on the register. The next one over goes to pin number 2 on the shift register. Bottom left goes to pin number 3. The next one to the right of it goes to pin number 4. Skip over the middle bottom pin, which is the common cathode, and that pin goes up to 5 on the register. The bottom right pin goes up to pin 15, that's the period. To the right of the cathode, it goes to 7, and the net one to the right goes to pin number 6 on the shift register. Here they are both connected and ready to test. Plug in the latch serial input and clock pin into your Arduino, and those pins are chosen in the code that you write. Connect the 5 volts out from the Arduino to the power of the on the rail, and then the ground to the ground rail. And I loaded up a simple sketch to test the shift registers, and let's see if it works. We have success. The code I wrote was to show a 59 on 2 shift registers. I don't want all these wires everywhere, and I want something more permanent. So I'm going to solder these 7-segment displays onto a prototyping board with the shift registers. So I started doing this and then realized it's really difficult. And also I realized that every LED needs its own resistor to protect it and to be as bright as possible. So this was going to be quite a job to hand solder everything together. So I decided to make a PCB board with everything I needed. I needed 8 resistors on it. I decided to go SMD to save more space on the PCB board. I needed my serial in, my latch, my clock. I needed everything to be able to be daisy chained as well, because I was going to daisy chain 5 of these together. I made my Gerber and drill files and went to JLC PCB, not a sponsor, but hey, I'm open to that. Uploaded my files, placed my order, and then in a week or 2, they came in. And they came out really good. Whenever you're able to simplify things into one PCB board, I highly recommend it. I will include these files for downloads in the notes in case you want to order your own for this project. I did some calculations and realized I needed 145 ohm resistors for each LED. I bought these 145 ohm resistors from Mouser.com. They are 12066 package. I tested them and bam, 145 and some change. Time to solder the resistors on. I've never soldered an SMD component on. This is my first time. So you put a little solder on one of the pads, then with your tweezers pick up the resistor and place it on top of the pads and melt the solder on one side, and then have it reform, and then solder the next pad. And don't worry if you mess up like I did and it's off, you can just reflow the solder and push it back onto the pad and it'll work great. Now do this for all of them. It's a lot to solder. You could solder the shift register directly onto the PCB, but I chose to put a 16-pin dip socket on in case I get a bad shift register or it breaks and I need to replace it. After you soldered the socket on, it's time to solder on the 7-segment display. Place it into the holes and solder away. Pop in your shift register and you are good to go. And if you compare the two, it's way prettier to design your own PCBs. Then I soldered on some long wires because I didn't know the length I needed to 5-volt ground latch serial in, and clock. And then daisy chain them all together. Time for the test, and it works. I'm going to use a buck converter to supply a steady 5 volts to my project and up to, I think, 2 amps of current. To set your buck converter to the correct voltage, you apply power to the input and then monitor the output on your multimeter. And I have 6.26 volts right now. Then there's a potentiometer, and you slowly adjust that in one direction until you get to your desired voltage. I've been using an Arduino Uno clone that costs about $16 to test everything out on this project, but I found these Arduino Nano clones on AliExpress for about $3 a piece in their USB-C. I'm going to use a DF mini player to play all the audio I need. It's a mini MP3 player with an SD card slot. Here are the pinouts from the manual. Voltage in, first pin. Serial receive, second pin. You're gonna receive information from your Arduino. If you're using a 5-volt Arduino, you're going to have to put a 1000 kilo ohm resistor on there. Pin number 3 is a transmit serial data pin. You're gonna set these 2 pins up as software serial on your Arduino. Then skipping down to pin 6, that is the negative wire to the speaker. Pin number 7 goes to ground, and also pin number 10 goes to ground. I've been advised to make sure both pins are grounded. Pin number 8 goes to the positive lead on the speaker. That is all you need to connect it to your Arduino. I also learned from a great YouTube video that I'll link below to put a 1000 microfarad electrolytic capacitor from voltage input to ground. It helps smooth out any voltage issues or jumps so you don't have any brownouts. I'm going to set up my DF mini player on a prototyping board and also have the power supply go to there as well. I'm going to solder the positive and negative wires from my buck converter across the prototyping board, and this is where I'll provide power and ground to everything in my project. Next, time to solder 4 buttons onto this prototyping board. These 4 buttons are going to control different parts of the scoreboard. One will be a pause play, one will adjust the period, one will adjust the time on the clock, and the other will reset the score values. Then I soldered long wires onto the buttons to attach to my Arduino Nano. Since I was on buttons, I went ahead and soldered the arcade buttons. Remember, there's a button here and also an LED, so you need 4 wires. I designed the entire scoreboard in Fusion 360, and here's a quick time-lapse of what that looked like. The link to all the STL files can be found in the show notes below. I started printing this project on my Ender 3 Pro, and this is my very first printer. I learned to print on it, but the results I was getting wasn't great because, as you can see, the bed at the corners was not flat and it was causing a curve, and also the arcade buttons wouldn't fit because their holes were oval. So I sold a bunch of stuff and bought an X1 Carbon from Bamboo Labs and started printing, and this thing is amazing. The prints come out perfect every time. It's a beautiful printer and it's super fast. I couldn't be more happy with it. Check out the unboxing video on my channel. As you can see, the print quality off the Bamboo is way better than what I was getting off my Ender 3 Pro, and I'm just extremely impressed with what this printer does. And here's the back panel fresh off the printer, and the moment of truth is seeing if the buttons fit. That is so satisfying when they are such a nice snug fit. Look at that, they stick out just a little bit, enough to know where the buttons are, and there are no gaps. Time to install the power switch and the barrel jack into the back panel. The hole I made for the barrel jack needed some adjusting, let's say. I fixed the STL file, so you shouldn't have to go through this, but I used it anyways, and then I added some glue onto the barrel jack to make sure it stuck into place and clamped it for a little while. It is time to make the lamp that will light up and look like it's spinning when someone scores. This isn't actually going to be spinning because that would complicate matters, so it's going to look like it's spinning. We will turn on and off 4 sections of the neopixels in sequence, and it'll look like it's spinning underneath the red translucent cover. Remove all the weatherproofing from the neopixels. I measured 12 neopixels to wrap around the inner part of the lamp, and then you can cut it directly across the copper pads. Then you're going to cut another strip of 12 and solder those together with a short bit of wire connecting the ground, power, and data lines, and then glue them onto the inner lamp. It is time to start assembling things permanently into place. First up are the 7-segment displays. Just set those into place and then screw an M3 screw into each of those holes. They don't line up super perfect, but they fit. Once those are screwed into place, you're going to set your clock in and screw that in with M2 screws. Both the M3 and M2 screws are 6 millimeters in length. Next, it's time to pop in your speaker. I just glued the speaker in with some hot glue in case something breaks and I need to fix it. It's not a permanent glue. Also, if it comes loose, it's very easy to fix with a little bit of hot glue. Then go ahead and slide in your arcade buttons and screw in that white piece to hold them into place. Let's put together the cage for the lamp. I put a little glue in the top notch and pushed those vertical pieces together to make the vertical part of the cage. And then you just press those rings up into the cage and the plastic will bend a little bit until you get the notches correct and it'll snap into place and hold those rings securely. Let's continue and put the lamp together on top of the box. The wires thread into the box and then glue the inner lamp with the neopixels into the inner circle, and then put the red outer shell on and do the same. Use some hot glue to glue the outer shell into place. Again, I'm using hot glue in case I need to get into things. I can take the box and lamp apart easily and then put it back together. A little bit of glue goes into those notches for the cage. Alright, everything is assembled. Now it is time to solder all the wires onto the Arduino and connect everything to power. I didn't want everything flopping around inside the box, so I created a little holder for the Arduino Nano, DF Mini player, and the buck converter so it would be held into place in the box. And this is what it looks like all finished. Everything nice and neat and not flopping around. I just hot glued the holder to the bottom of the box and I just put a little glue over the screw holes of the Nano to hold it into place. It's not screwed in. This was the first time I used a Arduino Nano clone, and it uses a different chip to interface with USB than the regular one, so I didn't have the driver, so I got a whole bunch of errors. So this is what you have to do. You have to Google the driver, the CH340 driver, and download your Windows, Macintosh, or Macintosh version and install, and then it'll work perfectly. Here is the code for the hockey scoreboard. I'm not going to go over it in detail, but if you want to download it and check it out, the link is in the show notes. Time to put the finishing touches on the scoreboard and glue all the labels onto the buttons. We've got score reset, select the time of the clock, the period select button, and the play and pause for the clock, as well as our score buttons, which are the arcade buttons. Then I'm going to glue on the home and guest and period labels. I know the home and guest are in opposite spots, but my son asked me to do it this way so he could be home and correspond to where he is when he plays. Then I'm going to hot glue the B, the most important part, on. I hot glued it in case the speaker breaks. I can easily take it off and make any repairs without destroying the whole project. And there it is, completely put together. So that is how you make your very own hockey scoreboard. You can theme it any way you want. If you have a favorite team you want to theme it after, go for it. I would love to see your pictures. If you dive into this, please send me a picture or video of yours. I would love to see what yours looks like. Until then, happy mini sticking.